going to not only prove triangles congruent, but we're going to go one step further. And before I get into that, let me first present these two diagrams to you, triangle ABC and triangle DEF. I'm telling you that they are congruent. If you know the triangles are congruent, who could tell me what we know about angle A and angle D? Kevin?
Angle A and D are congruent?
Yes, because if the triangles themselves are congruent, then we know that the angles, the corresponding angles, are congruent. Then, basically, what do we know about all the corresponding parts? Arden?
They are all congruent.
They are all congruent. So we could make a list. We could say we know that angle A is congruent to angle D. We can mark that on the diagram. We know that angle B is congruent to angle E. And angle C congruent to angle F. And we could also list the corresponding sides. We could say AB congruent to DE. We know that BC is congruent to EF, and that AC is congruent to DF. And what we're learning today is that corresponding parts of congruent triangles are congruent. That's our theorem. If you know triangles are congruent, then you know all their corresponding parts are congruent, all their matching sides and angles. We can abbreviate this with the letters CPC, TC. When you're using corresponding parts of congruent triangles are congruent in a proof, you are allowed to say CPC, TC. Now, it's important that you don't get CPC, TC, the letters, mixed up. So if you're going to use the abbreviation rather than writing out corresponding parts of congruent triangles are congruent, make sure that you know what it stands for and that you don't get the letters mixed up. Because if you mix up the order on a test or a quiz, I will take off a half a point or so. All right. Another thing we need to cover today is a radius, right? So AP, if P is the center of the circle, then we could say that AP is a radius of circle P. And the book will use a circle with a dot in it to represent circle. And that tells you, if they call it circle P, that means the center of the circle is the letter that's next to it. P is the center, yes. Can you name, how do we know P is the center? Because P, this point here, was in the center. The book will be a little more explicit about having a dot in the center to tell you that that's the center of the circle. No, they'll have a dot to tell you. My diagram didn't have it, that's why I drew one. Who could name another radius of the circle? Nicole.
PC.
PC, and Blake?
BP.
Oh, we got this one already, but there's one more. We have AP, we have PC, we also have Arden?
PB.
PB. Good. Those are all radii. We don't say radiuses. They're all radii. And all radii of a circle, of the same circle, are congruent. So that is another theorem that we can use today from now on. If you have segments, radii, in one circle, you know that all the radii will be the same length. Okay, so how do we use corresponding parts of congruent triangles in a proof? Turn it over. All we are given in this proof is this diagram. We're given circle P. So because I told you that we're given circle P, we can assume P is the center of the circle. Okay? So we're given the diagram. We have to start assuming things now from the diagram. What's one thing that we can assume? Luis.
That PB is a radius.
PB is a radius, so what would PB be congruent to?
It would be
Good. We know all of them are congruent, so we can just put it all in one string. PB is congruent to AP, which is congruent to PC, which is congruent to PD. All radii of a circle are congruent. Now notice what we're trying to prove isn't that the triangles are congruent. We're trying to prove that AB is congruent to CD. But we have to prove the triangle's congruent first before we can do that. So reason for step 2 is simply all radii of a circle congruent. Notice it's not in the if-then form. This is one of the exceptions. Yes, Nicole?
For step 3, can we say angle APB is congruent to angle CPD because vertical angles are congruent?
We certainly should say that. Angle APB congruent to CPD. Vertical angles are congruent. Mark that on our diagram. So, can we prove the triangle's congruent now, Samantha?
Yes, we can prove that triangle APB is congruent to triangle CPD because of side, angle, side, that's 2, 2, 6.
Good. So let's actually put 3 in the middle, because angle was in step 3, and then step 2. Now, we learned just a moment ago that if we know the triangles are congruent, then we know all the corresponding parts are congruent. Well, we were asked to prove corresponding parts congruent. So our last step, after you prove the triangle's congruent now, is to say that AB is congruent to CD, and all you need to say is CPCTC. Corresponding parts of congruent triangles are congruent. Good job.